Hi, my name is POLYCARP and I will present transmission line in this video. This is the transmission line. Okay, let's see. There are three types of overhead transmission line, which is short transmission line, medium transmission line, and long transmission line. Right. Then we proceed to the design. So first, the design will depends on the tower varieties, and then clearance requirement. You can read here about all the details, and then reliability standard. So clearance criteria, they need to meet certain standards enable it to proceed for the design. So okay, constructions. These are the things that we I'll say these are the equipment materials for overhead transmission constructions. So there are ABI switch, there are conductor, CML conductor, HV aerial bundle cable, LV aerial bundle cable, and LV PVC covered aluminum conductor. And next they have PDO or ABFI for this are the list. And insulator, uh, overhead connector, poles, and last but not least, overhead assemblies. So, okay. Lastly, we'll proceed for the operation of each component. So, as you can see, the transmission lines, the primary function of transmission lines is to structures to provide mechanical supports to connecting. This is achieved by maintaining mechanical integrity without permanent structural deformation under ultimate load condition, while is preserving structure geometry to retain operational electrical clearance under prescribed serviceability and ultimate load conditions. So these are the secondary of transmission lines. R2 ensures safety of people and the environment. Maintain structure geometry preserve. Maintain safe approach distance for stability. And provide electrical path. Provide a whole of life cost effective service. And so these are structure types of includes freestanding and guides. Lattice tower, steel tubular poles, so B poles and concrete poles. Yeah, they use what type of poles for structure. And transmission line conductor. The primary function of transmission line conductor system is to transfer electrical power between designated location within prescribed performance, operating in environmental conditions. So these are the secondary function of transmission line conductors is to maintain electrical safety, minimize adverse effect on the environment, provide a whole life cost effective service. Transmission line insulator, they have two primary functions, which is to insulate energized components from earth structure and rated operating voltage and specified switching and lightning impulses to support the conductor system up to ultimate mechanical load limits and transfer the mechanical loads to structure. And the transmission line hardware has four primary functions, which is to support insulator system up to electrical limits, to support insulator up to ultimate mechanical load limits, provide effective attachment interface between conductor and insulator, and lastly to provide a whole life cost effective service. So these are the four primary functions for transmission line hardware. And next we go for transmission line earthing. Right, so transmission line earthing, their primary function of a transmission line earthing is to provide electrical path, ensure the faults clear with any R times limit, provide an earth potential reference to ground under normal circuit conditions for the dissipations of leakage currents. Next, secondary function of requirement transmission system for its design. IFR2 maintain electrical safety, minimize adverse effect on environmental, and provide an effective technical solution. And the third is, again, provide a whole of life cost-effective service. Transmission line earthing relate to aerial earthing, ground level earthing, communication hardware. So there are relates to three things. Next, transmission high voltage cable. Uh, the primary function of transmission high voltage cable is to transfer electrical power between designated locations within prescribed performance, operating and environmental conditions, and to isolate energized component from its structure at rated operating voltage and specify switching and lightning impulses. So basically, the secondary function of is more or less the same like the others. Uh, the high voltage cable component are joints, sealing ends, sealing boxes, partial discharge detecting equipment, commissioning, monitoring system, or distributed temperature sensor. Next is cable trench, joint base, laying box equipment pits, support structure, expansion chamber. That's it from me. Thank you.
Hello and a very good day to Madam Nobahira. Today I'm going to explain about transmission and distribution substation. My name is FRANKLYN and I'm from 2BEI section 1/2. So, what is transmission substation? A transmission substation connects two or more transmission lines where the three-phase electricity leaves the generator and enters the transmission substation at the power plant. This substation utilizes huge transformers to step up or convert the generation voltage to high voltages for long-distance transmission on the transmission grid. It typically ranges from 110 kV and above. Alright, next. What is distribution substation? A distribution substation transmits electricity from the transmission system to the area's distribution system. For example, 11 kV to 415 volt of three-phase, where it connects to the customer's houses. The input for distribution sub is normally at least two transmission or sub-transmission lines. The voltages for distribution substation usually ranges from 33 kV to 11 kV or lower. So, what is the difference of transmission substation and distribution substation? Transmission substation uses high voltages, which is around 110 kV and above, while for distribution substation, the voltage operation is medium or low, where it is around 33 kV to 11 kV. For transmission substation, the general measuring and protection equipments are outdoor, while for the distribution substation, measuring and protection equipments are indoor. And next, the distance and differential protection is used for transmission substation, while for distribution substation, the distance and differential protection is not commonly used. And finally, the transmission substation is not connected to consumers directly, while it is connected to consumers directly for distribution substation. So I'm about to explain about distribution substation, which is for Sarawak, where we uses the 275 kilovolt from the transmission line to 33 kilovolt. The distribution substation step down the 275 kilovolt from the transmission line to 33 kilovolt. The voltage must be stepped up and down multiple times in various substations as it travels from generating substation to the end users. This is to ensure the efficient transmission of power, thus it minimizing the power losses. And then for the distribution solution of 330 kilowatt to 11 kilowatt, the distribution solution of 33 kilowatt to 11 kilowatt was used to step down the voltage of high tension of where it is 33 kilowatt to 11 kilowatt to make the voltage more suitable for distribution. The transformer used for this is a step down transformer, and then for the end users, which is for example this distribution solution of 11 kilowatt to 415, where it was used to distribute three-phase 415 volt to the surrounding subload. The substation is considered a distribution substation as it distributes a low tension of voltage of around 415 volt. It is also a step-down substation. And finally, I'm going to explain about the construction of a power transformer. So this is the construction of the power transformer, where the number one is the low voltage pushes, where it is used to insulate, and the second is insulators, where it provides insulation between the energized part, and third, the terminal box, where it allows the connection between wire inside and the outside of the transformer tank. For the number four is the outgoing from the transformer. It is a step down voltage from the transformer, and the fifth is the main tank, where it protects the core and the winding from external environment. And number six is the medium voltage pushing. And number seven is the pylon pole, where it supports the electrical cables from transmission power lines or the generating power lines. And the eighth is the insulating oil is inside of the tank. The insulating oil is used to insulate, suppress corona discharge, and arcing, and it is used to serve as a coolant. Next is the construction from the outside of the power transformer, where the number one is the transformer radiator fans. It helps to remove the dissipated heat and use the ambient air to cool down the transformer. And the number two is the radiator fin. It is used to accelerate the cooling rate of transformer. And number three is the oil conservator. It provides adequate space for expansion of oil and used for the reservoir for the insulating transformer oil. Number four is high voltage pushing, where the high voltage pushing isolate the conductor between the overhead line and the transformer winding. The fifth is the glucose relay. It gives the protection to a transformer from the different faults happening in the transformer. And next is the power transformer protection. The power transformer has a protection which is the built-on protection. Where, for example, the glucose relay for dielectric failure, oil pressure and level switches, thermostat for oil temperature, and on-load tap changer protection. The second is the differential protection. It is used to compare the current entering the piece of equipment with the current leaving it, where under normal healthy condition the two are equal. If the two currents are not equal, then a fault must exist. Third is overcurrent protection, where it has a mechanical latch to indicate the fusion and to provoke three-pole opening of the switch disconnector to avoid the functioning of the installation only with two phases. And the fourth is overload protection. It has the thermal overload relays to protect the transformers from overload. This method of protection stimulates transformer winding temperature. The simulation uses the transformer's thermal time constant and current measurement. And lastly, it has lightning protection. The protection of power transformers is achieved by a surge arrestor installed in the transformer. That is all from me, madam. Thank you.
Selamat sejahtera. My name is Patricia JELAWAI and David, and my matric number is B0820103889, and I'm from 2B I1/2. So today I would like to explain about distribution line. What is distribution line? Distribution power lines are for shorter distances and lower voltage electricity transportation. Distribution lines have two types, which is overhead and underground. These both carried 33 kilovolt or 11 kilovolt. But today, I will just explain about overhead distribution line. For the first picture is 33 kilovolt 11 meter high tension wood monopole, and this one is 11 kilovolt 11 meter high tension steel monopole. But for this one is 240 volt 9 meter low tension steel monopole. Okay, this one is actually the carried home standard electricity, which is 240, because in front of these lines actually have transformer that will be stepped down 11 kilovolt to 240 volt. Okay, this one is air breaker circuit insulator. Okay, this is the example, and this one is this insulator. Okay, for 33 kilovolt, actually mostly will be used in city, but for 11 kilovolt will be used in rural area. Okay, how we know this one is 11 and this one is 33? Because this insulator for 11 kilovolt is 2, but for 33 kilovolt is 4. Okay. Next is the function for ABFI and this insulator. For air breaker fuse isolator is mechanical switches which isolate a part of a circuit from system as when required. This isolator separate a part of the system from rest for safe maintenance works. Okay, for the second one is this insulator is for support conductors to insulate cables and electrical wiring. That's all from me. Thank you.